Now let's compare and contrast the characteristics of a table that represents a linear function, a quadratic function, and an exponential function. So what I've done here, you've done hundreds of times before, looked at the change from this x value to this x value. It's a change of when we added 1 to get from -1 to 0. Added 1, added 1, added 1. So plus 1 right here is the change that's taking place in the x values. And notice it's going to do that across the board. It doesn't have to be a plus 1. It could be a plus 2 or whatever, but it's most often a plus 1. On the y side, though, we see that to get from 8 to 6, we see that's a change of -2, a change of -2, a change of -2, a change of -2. This is called a constant change, and it's the fact that every one of these numbers right here is a -2. That's how I know it's linear. Okay, and we use the word additive right here to explain the change because that's what we're doing. We're adding a -2 to each one of these y values, and that helps us find the slope. Since we know it's linear, we find the slope by taking this change in y and comparing it to the change in x and reducing it down if we need to. So that's how we find the slope, and the slope is called the constant change. It's a constant additive change because we're adding a -2 each time. Over here on a quadratic, I've already done the plus 1 on the x values, and I tried it on the y values. I did not get a constant additive change. So all that tells me is, so far, it means it's not a linear function. But what's unique about quadratics is if I do another set of differences, this is called the first set of differences. If I do another set of differences, in other words, what's the change of those changes, of those first changes? What do I have to do to get from -1 to a +1? Well, that's an adding of 2. And to get from a +1 to a +3, I have to add 2. To get from a +3 to a +5, I have to add 2. This second set right here, the second set of differences is a constant additive change. That tells me that I have a quadratic. Every quadratic will have a table of values that will have a constant additive change in the second set of differences on the y values. That's how I know it's a quadratic. Now look over here at exponentials. Exponentials have an additive change in the x values, but the y values are not an additive change. It is a constant, okay? I see a constant, but you can't just stop and saying it's a constant, because then I wouldn't be able to tell this constant change against this constant change. If all you said is, yes, it has a constant change, then you're only giving me half the information that I need. This is a constant multiplicative change. Constant multiplicative change. That means I have to multiply, my lights are going off. It means I have to multiply each y value by 2 to get the next y value. 1/2 times 2 is 1. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. Does not have to be a positive number. It doesn't have to be a number bigger than 1. It can be a fraction, because as you can see right here, I have the plus 1s all the way down here. Plus 1, plus 1, plus 1. And then over here, what do I multiply 27 by to get to 9? Well, that would be 1/3. What do I multiply 9 by to get 3? That would be 1/3. What do I multiply 3 by to get 1? That would be 1/3. That is 1/3. And that's a multiplier. Okay? Remember, multiplying by 1/3 is the same thing as dividing by 3. So if you had written down right there, divide by 3, that's okay. You would just need to change that to multiply by 1/3, because what do we need right here in order for it to be an exponential? We need a constant multiplicative change. So it needs to be a multiplier. So if you see that I can take each one of these and divide by 3, just remember that dividing by 3 is the same thing as multiplying by 1/3, and that's where you get your multiplicative change.